So completing the square is a mondo huge important skill to have here. And I urge you to look at the notes as well. There is some sort of taking a half and squaring it kind of a thing. For instance, I'm looking at these two terms right here, this x squared plus 4x. And I know that this is going to be part of some perfect square. I know that eventually I want to have an x plus something squared or an x minus something squared. By the way, do you already know, is it going to be an x plus something or is it going to be an x minus something?
It has to be plus.
Why do you say that?
Because both the plus 4, well, actually, all the values are positive, so.
And to be quite frank, it's this one that gives it away. We're going to have an x plus something quantity squared. Any guess what that something is?
Well, you can't put 2 because it's not. But if you. Hold on.
Yeah, take your time.
Yeah, but if you're. Wouldn't that yield plus 4 instead of plus 3?
It would. So I'm thinking if we were to multiply this out, we would get x squared plus 4x
Plus 4.
plus 4. So that's not what we have.
Oh, that's
Not exactly what we have.
Yeah.
Is there any way to sort of
You want to obtain that, though.
obtain it, manufacture it?
You have to add 1.
So we'd have to add 1 to our original.
Right.
Now here's my claim. Now we've got right here in total, we've got that perfect square trinomial we want. This right here, like you said, is just x plus 2 quantity squared. You okay with that?
Yeah.
Now here's the deal. I mean, we got an equation. You can't just add 1 to one side of the equation. What else must we do then?
You have to add it to the other side.
You got two options. You can either go ahead and add it to the other side as well, or to be quite frank, what I prefer to do is to subtract it from the same side we just added it to. We just added 1 and subtracted 1 from the same side of the equation. I think that's
like we did nothing.
It's like we did nothing, and I think that's totally okay to do. And so what does that leave us? Well, this part right here is our x plus 2 quantity squared.
Minus 1.
And you know what? I think we just put this guy in a vertex form. I think that we are totally ready to graph him. So I think we know exactly how that compares to our regular y equals x squared graph. Tell me about this one right here.
It moves left 2 and down 1, and that's really it.
Compared to our y equals x squared, no problem. So I'm just going to kind of put this here. So I'm saying it looks like in order to go from our equation in red, y equals x squared, to the one in maroon, go left 2, down 1. No big deal. I mean, this is great. What about the vertex of our guy in brown?
-2, -1.
Axis of symmetry?
X equals -2.
So I'm going to go ahead and graph some of these as you do it as well. -2, -1. Our vertex, I'm seeing an axis of symmetry. X equals -2, that line right there. Okay, awesome. Up or downward facing?
It's upward.
So I kind of like at this point to just make a quick sketch and say, you know what, I think that's more or less what it'll, very rough sketch. You don't even have to draw it, but I like to have that in the back of my mind.
Yeah.
Okay, what are some other things we'd like to know about this graph that might be helpful?
Probably it's X-intercepts.
X-intercepts, talk to me. How do you want to find them?
We can just set y to 0, so 0 equals x plus 2 squared minus 1.
So 0 equals x plus 2 squared minus 1. Take it away.
You add 1, so 1 equals x plus 2 squared.
All right.
Find the square root. 1 equals x plus 2. And you just subtract, or plus or minus 1.
Good man, good man.
Subtract 2, so x equals -1 or x equals -3.
Awesome, awesome, awesome. Now note to self, our little rough sketch here was pretty close. I mean, it was not awesome, but it was close. And, all right, so we've got -1, -3. Now note to self, not a huge deal. we actually could have factored this original one as x plus 3, x plus 1. Just another way to see it.
Yeah.
Now here's my claim. I actually like the strategy you took by inserting it here using our vertex form. Why? Imagine that the original one did not factor.
Right.
We'd have to complete the square. But here's my claim. I mean, you already completed the square.
Right. Yeah, yeah.
So you know what? Hey, and if you get nice answers like -1 and -3, I mean, no harm done, right? We found the exact same X-intercepts. But if we ever get some really gnarly ones like we did in class, hey, you know, we've already done half of the work there. Awesome, awesome, awesome. What about the Y-intercept for this graph?
I mean, you just have to set x equal to 0, but, so, let's see, y equals 0 plus 2 squared minus 1, so it'd just be 4 minus 1, so it'd be 3.
Absolutely, and here's my claim. You actually don't even need to work so hard. If you look at our original again, here's your Y-intercept.
Yeah.
So the standard form of a quadratic, useful for just about nothing, except finding the Y-intercept, which is pretty sweet. So we've got our Y-intercept of 3. We can graph that. And I think that also gives us another free point, namely...
The, whatever, I guess the opposite, or, no, that's not the best word.
No, opposite is okay. If you were to give it a name, like what are its coordinates, what would they be?
Oh, -4, 3, and, well, that's the opposite.
Totally. And you know what? I'm feeling pretty good about graphing this parabola. If you want to find another ordered pair, you can, but I'm feeling pretty confident about it.
Yeah.
And I think we can pretty much go right ahead and sketch it, and I think it's more or less what we end up with. So what I want to do is I want to do another example, a little bit harder though.
Yeah.
Okay, and what I'm also doing is